Imagine a 15,000-pound chunk of dead rocket slammed into the lunar surface at 5,400 miles per hour. This just happened on August 5th, 2026, at 6:34 and 32.9 seconds UTC. Here's what most people assume about space junk: that someone is watching it, that if a piece of a rocket is drifting toward the moon, some agency has a plan, a tracking system, a button to push. That assumption is wrong, and this is the story of the object that proved it. An object that hit the moon in a place we could actually see for the first time in history. By the end of this video, you will understand why this is an absolute sensation. Those aren't my words, those are the words of Bill Gray, an independent astronomer who has spent years writing the software that tracks deep space debris, essentially alone, without a government paycheck. Gray's program, designed to catch exactly this kind of threat, was the one that flagged the object's trajectory months in advance. Not NASA, not the US Space Force. One person, one laptop, one piece of open source code. The object was the second stage of a SpaceX Falcon 9 rocket, launched back in January 2025. Once it delivered its payload, its job was done. No fuel left, no power, no radio contact. It became, in the most literal sense, dead weight. A hollow steel cylinder the size of a school bus, tumbling silently through space. For over a year it drifted, not steered, not monitored, just pulled along by the only two forces still acting on it: Earth's gravity and the faint push of sunlight on its metal skin. Slowly, invisibly, those forces bent its path until it locked onto a collision course with the moon. Nobody put it there on purpose. Nobody could have pulled it back. Here's the part that should unsettle you. This has happened before. In March 2022, a rocket body slammed into the moon's far side, the side permanently turned away from Earth. It was eventually traced back to Chinese rocket hardware, though the origin was disputed for months. That impact was invisible to every telescope on the planet by definition. We couldn't watch it. We couldn't confirm it in real time. We only found the crater later in orbital photographs. That should have been the wake-up call. It wasn't. But this time was different. This impactor was headed for the near side, the face of the moon we actually see every night, near a crater called Einstein, right along the visible edge. For the first time in human history, we had a predicted lunar impact from a known object that telescopes on Earth could actually try to watch. But wait, there is more. So astronomers pointed their instruments at the edge of the moon and waited. And here's the twist. They knew going in that they probably wouldn't see the flash. Why? Two reasons. First, the impact site was in daylight on the moon, washed out by sunlight, the same way you can't see a candle flame in a bright room. Second, at 5,400 miles per hour, this impact was almost gentle by cosmic standards. Fast enough to vaporize metal, but slow enough that the flash of light would be faint, brief, and easy to miss. That should have ended the story right there. A blind impact, no visual confirmation, case closed. But it didn't. Because even if you can't see the flash, you might see what comes after it. When something hits the moon at thousands of miles per hour, it doesn't just make a crater. It throws a curtain of pulverized rock hundreds of miles into space. No atmosphere to slow it down. No wind to disperse it. Just a silent plume rising off the edge of the moon, briefly visible against the black backdrop of space, backlit by the sun. That's what observers were really hunting for. Not a flash. A shadow of dust climbing off the edge of the world we've stared at our entire lives. Visible proof from Earth that something we launched had come back to strike the thing that inspired us to launch it in the first place. And here's why scientists weren't just watching for a show. This impact is, in a strange way, a gift. Normally, when something hits the moon, we have no idea what hit it, how fast, or at what angle. We find a crater and we guess. This time, we knew everything in advance. The mass of the object, its exact speed, its angle of approach, down to the second. That turns this impact into a calibration point, a known input with a measurable output, the size and shape of the resulting crater. For scientists building the models we would use in a real planetary defense scenario, the kind where an actual asteroid is heading toward Earth, a precisely known impact like this is almost impossible to get any other way. You cannot ethically fire a rocket stage at Earth to test your models, but nobody stopped this one from hitting the moon, so scientists made the most of it. There's one more thread researchers are pulling on. Spacecraft fuel, the trace chemicals left in these dead rocket stages, can leave a spectral fingerprint. Scientists are specifically watching for a lithium signature in the debris, a marker that could help distinguish rocket body impacts from natural meteorite strikes going forward. And that matters because of the unsolved mystery sitting right next to this one, that 2022 far side impact. It didn't leave one crater, it left two, a double crater sitting side by side which no one has ever fully explained. Some suspect an unknown counterweight bolted to the rocket body. Nobody has confirmed it. This new near-side, precisely documented impact might finally give researchers the comparison data they need to understand what really happened out there. A mystery hiding in plain sight, 90 million square miles from home. But strip away the science for a second, and there's a much bigger question sitting underneath all of this. Bill Gray didn't find this impactor because a space agency assigned him to. He found it because nobody else was looking. There is no formal binding system that tracks or manages dead rocket hardware once it leaves Earth orbit and drifts toward the moon. Radar, the tool we use to track satellites near Earth, is useless at lunar distances. The signal is too weak to bounce back. Past the reach of radar, cislunar space is essentially a blind spot, watched over by volunteers with software, not governments with satellites. And the frustrating part is, this is a solvable problem. Some rocket operators already use something called heliocentric disposal, deliberately steering a dead stage onto a path around the sun instead of leaving it to drift near Earth and the moon. It's a known fix. It's used sometimes, just not consistently and not by everyone. Right now, dozens more dead rocket stages are drifting through the same dark corridor between Earth and the moon. Untracked, unpowered, unaccountable to anyone. Some of them are on paths we simply haven't calculated yet. As lunar missions multiply, landers, orbiters, eventually astronauts, that empty stretch of space is getting crowded, and almost nobody is watching it.